Welcome to this custom-tailored deep dive. When you walk into a sports bar or maybe a control room and you see this massive, perfectly synced wall of television?
Oh, yeah, it's totally mesmerizing.
Right. But today, our mission is exploring the invisible tech that actually powers those massive multi-screen video walls. We are using the specs and reviews of a specific WolfPack switcher from HDTV Supply to do it. Okay, let's unpack this, because the best way I can describe this device is to think of it as a high-speed digital traffic cop.
A traffic cop. Okay, I like that.
Yeah, it's basically standing in the middle of a massive digital intersection, just directing 8 different video streams to 8 different TVs and keeping everything moving without a single crash.
Exactly. And I think we need to elevate that analogy just a bit, because while you and I are just staring at the bright, shiny screens, the real magic is happening entirely out of sight inside that routing box.
Fair enough. Well, to understand how this digital traffic cop actually works, we have to look at its specific title and the specs. And there is a very strict rule pulled directly from our source material here.
Oh, right, the naming convention.
Yes. We must refer to this device as an 8x8 matrix, never an 8x8, and definitely not an 8EX8, strictly an 8x8.
Yeah, that terminology is highly specific for a reason. What this 8x8 actually does is take 8 separate HDMI inputs. Yeah. So like a Blu-ray player or a couple of cable boxes, maybe a game console, and routes them to 8 HDMI outputs.
At 4K resolution, right?
Exactly, at 4K resolution. Though it is running at 30 hertz, complete with smart heat management.
Wait, 30 hertz? I mean, for a $2,000 device, isn't 60 hertz usually the standard for 4K?
Usually, yeah.
That feels like a notable trade-off. And also, what even is EDED management? I'm picturing our traffic cop pulling data streams over to check their driver's licenses, but that can't be right.
Well, it is a trade-off, yes, but it's totally necessary for the sheer processing power required for 8 simultaneous 4K streams. And think of EDED, less like a traffic cop checking IDs, and more like a diplomat negotiating a treaty before the video even plays.
Oh, okay, so it's negotiating.
Yeah, it's the TV telling the Blu-ray player, hey, I only speak 4K at 30 hertz, so don't bother sending me anything else. The Matrix manages that conversation in the background, so the source always sends the optimal resolution to the right screen.
But, I mean, all that automated resolution matching is pretty much useless if the viewing experience is clunky. Which is why this 8x8 has a feature called seamless switching.
Right, the seamless switching is huge.
Yeah, it completely eliminates those annoying black or blue screen delays when you change sources.
Yeah.
How is it actually doing that without a single delay?
What's fascinating here is the mechanism behind it. To make it truly seamless, the Matrix actually has to hold the incoming video streams in a temporary memory buffer.
Yeah, wait, so it just holds the video back?
Yeah, exactly. It lines up the digital frames perfectly in the background and swaps them precisely between the refresh cycles of the TV. Your eye literally cannot catch the break.
That is incredible.
Oh, it really is. Plus, it manages up to 20 save scenes and performs what's called bezel correction.
Here's where it gets really interesting, because I have always wondered how a football moving across 3 screens doesn't look like it's just teleporting when it crosses the plastic frames of the TVs. How does bezel correction actually solve that?
It's just brilliant math, honestly. The Matrix actively renders the full image, but it mathematically calculates the physical width of those plastic TV borders.
Okay, so it knows how thick the plastic is.
Right, and then it intentionally throws away perfectly good pixels that would fall behind those borders. It's actually simulating the physical blind spots of the real world.
Wow, tricking your brain into seeing a single unified canvas.
Exactly.
That is wild. It's literally hiding reality to make the illusion perfect. But of course, all that automated pixel stitching is useless if you can't actually tell the box what to do. You have to control it.
Yeah, you definitely need an interface for that.
Right, whether through a simple web browser interface, it's a Web GUI, or for the hardcore techies, old school RS-232 serial connections.
Right, the sheer variety of control inputs shows this thing is really built for professional environments. But the contrast between the high-end tech and the human element is pretty striking.
It really is. I mean, I have to laugh at the specific 4-star review from a customer named John M. He loved the hardware, but he specifically noted that the support staff was, and I quote, less than friendly, but answered my question.
That is too funny.
Yeah.
If we connect this to the bigger picture, it is a hilarious reminder of the limits of hardware.
Oh, totally.
Despite this device having a 96% top-tier rating for being a perfectly seamless digital powerhouse, It still ultimately relies on endearingly grumpy human support to function properly in the real world.
So what does this all mean? Why should you care about this invisible box? Well, the next time you see a massive, glitch-free video wall, you'll know exactly what kind of hardware and what kind of pixel-throwing math is quietly running the show.
This raises an important question, though. Think about our digital traffic cop. If a single box can seamlessly stitch and scale reality across 8 screens with zero delay today, simulating physical blind spots in real time, how might future iterations completely manipulate the live visual environments we perceive without us ever noticing a single digital glitch?